In today's class, we'll learn about the problems on Fourier transform. The problem is find the Fourier transform of f of x is equal to 1 minus mod x, where mod of x is less than equal to 1 and 0 mod x is greater than 1, and hence deduce that integration 0 to infinity sin square t upon t square into dt is equal to pi by 2. The solution of this problem we'll see now. The problem is find the Fourier transform of f of x is equal to 1 minus mod of x for mod x less than or equal to 1, 0 for mod x strictly greater than 1, and hence deduce that integration over 0 to infinity sin square t upon t square into dt is equal to pi by 2. So this is a given question and we need to find a Fourier transform now. The solution. So first we'll collect the given function f of x, that is f of x is equal to 1 minus mod of x for mod x less than or equal to 1, 0 for mod x strictly greater than 1. So here second part is 0, so I will neglect the second function of f of x. So therefore function f of x is equal to 1 minus mod x for this mod x less than or equal to 1 can be written as what here, x greater than or equal to minus 1 and less than or equal to plus 1. So once we get this, so again you can observe here the function f of x having what here, mod x. So here what happens, again f of x is equal to, because mod x is nothing but minus x and plus x, so as we have seen in one of the example, again I will see here, so it is lying between what here, minus 1 to plus 1, 0. So here we have mod x, so if minus 1 to 0 we have actually minus x, and from 0 to 1 we have plus x. So mod x is nothing but from in between mod x is what here, in lying between minus 1 to plus 1 is mod x, but here from minus 1 to 0 we have minus, and 0 to 1 it is plus, but we have a question is what here, 1 minus of mod x. We'll see here, just see. So 1 minus of this mod x is nothing but mod x for, I will write the interval x greater than equal to minus 1 and less than or equal to 0. So for minus 1 to 0 it is minus x, so I'll write minus times minus x, and similarly for x greater than equal to 0 but less than equal to 1 is nothing but 1 minus of this plus x. So therefore the function f of x will be arranged as 1 minus of minus is what here, plus x between x greater than equal to minus 1 less than equal to 0, and 1 minus into plus is again minus of x, where x greater than equal to 0 but less than equal to 1. So therefore, so by using this function we need to go for what here, a solution of the given transform here. So therefore by definition of Fourier transform, that is nothing but f of u is equal to integration minus infinity to plus infinity f of x into e raised to I u x dx. Therefore f of u is equal to, we have the limit what here, two limits we have, so I will take that limit directly. So actually it is -1 to +1, but -1 to +1 is again we have two functions. For -1 to 0 we have 1 plus x, and from 0 to x we have what here, another function. So I can or else this can be written as -1 to +1. Function f of x is what here, if you consider this, it is 1 minus mod of x into e raised to iux into dx. But 1 minus mod of x is again addition of two integrals, so -1 to +1 can be written as -1 to 0. So first what here, 1 plus x into e raised to iux into dx, plus another limit is integral is what here, 0 to 1, 1 plus 1 minus x, the second part, into e raised to iux into dx. So this integrals we need to simplify. So by Bernoulli's integral by parts, or by rule better, so it is nothing but, so f of u will become, so first integral, keep 1 plus x as it is, integration of e raised to iux is e raised to iux divided by iu, formula minus differentiation of 1 plus x with respect to x is 0 plus 1, 1 upon iu will carry in the next step, and integration of e raised to iux is what here, e raised to iux divided by iu. Differentiation of 0 plus 1 is what here, 0, so we'll stop it and say with the limit what here, 0 to -1 to 0, plus next second integral, I'll write it down here, plus bracket integration of 1 minus x into e raised to iux by Bernoulli's, that is keep 1 minus x as it is, integration of e raised to iux is what here, iux divided by iu, formula minus differentiation of 1 minus x is what here, 0 minus 1 into 1 upon iu, integration of e raised to iux is what here, e raised to iux divided by iu, differentiation of 0 minus 1 is again 0, close the integration and simplification with the limit what here, it is 0 to 1. So now we need to rearrange and we need to apply upper and lower limit. So therefore f of u is equal to, first I will rearrange, so it is 1 plus x into e raised to iux whole divided by iu. So 0 plus 1 is 1, this into minus is what here, minus e raised to iux divided by iu into iu, it will become I square u square, -1 to 0. I have not applied the limit, we just I am arranging first. Second term is 1 minus x e raised to iux divided by iu, minus into minus is minus, minus into minus is plus, then e raised to iux divided by iu into iu, it will become I square u square from 0 to 1. So once we got this, now we will apply the what here, upper and lower limits. So therefore f of u is equal to, we will apply upper limit. If you replace x is equal to 0 as upper limit here, that is 1 plus 0 will be what here, 1 into e raised to iux, that is e raised to 0 is what here, 1 upon iu, that is 1 upon iu. So again repeat, so if you replace x is equal to 0, 1 plus 0 into, otherwise I will write 1 plus 0 e raised to I u 0 is what here, e raised to 0 minus, then if you replace again here also 0, it will e raised to 0 upon I square u square. This is upper limit minus lower limit is, if you replace x by what here, minus 1, so this minus 1, so I will write it here 1, already we have 1, x will be minus 1 means minus 1 e raised to minus I u divided by I u minus e raised to minus I u divided by I square u square. So this is for first what we have for minus 1 to 0. Second one, plus sign. So we replace x by 1, so it will become 1 minus 1 e raised to I u divided by I u plus e raised to I u, x will be replaced by what here, 1, so therefore e raised to I u divided by I square u square. First term minus, if you apply a lower limit, it will become 1 minus 0 e raised to 0 divided by I u plus e raised to 0 divided by I square u square. So be careful while applying the limits. So once we got these limits, so we'll go for what here, simplification. So what's simplification here, we'll see. So 1 plus 0 is 1, 1 into e raised to 0 is what here, 1, so we'll get 1 upon IU. So e raised to 0 is what here, 1, so 1 upon I square is nothing but minus 1 into u square. So then next, so this will next one, so 1 minus 1 is what here, 0, 0 into this entire term will become what here, 0, but here, so minus minus it will become plus, e raised to IU it will remain as it is, e raised to IU divided by I square is nothing but what here, minus 1 into u square, plus into plus is plus, again we'll check what is the sign, because here 1 minus 1 is again 0, so this entire term will become 0. So then we have e raised to IU upon I square, so plus plus is plus again, so e raised to IU divided by I square is again minus 1 into u square. Then 1 minus 0 is 1, 1 into e raised to 0 is what here, 1, that is 1 into 1 is 1, so again minus 1 upon IU. So minus into plus is again what here, minus e raised to 0 is 1 upon I square is minus 1 into u square. So this is the complete simplification after applying the upper and lower limit. So which is nothing but f of u is equal to, so this first term, this term and this term get cancelled, so this minus minus plus, so 1 upon u square plus e raised to, so plus into minus is, this will become minus e raised to IU divided by u square, so plus into minus is minus here, so plus, again plus into minus is minus e raised to IU upon u square, then minus into minus is plus 1 upon u square, so which is nothing but f of u is equal to 1 upon u square, 1 upon u square, it will become 2 upon u square minus e raised to IU. So here actually one of the sign, this is minus sign, so here among this this is also minus sign, among this you take minus sign common and 1 upon u square common, inside we have left with what here, e raised to IU plus e raised to minus IU, which is nothing but f of u is equal to 2 upon u square minus 1 upon u square, so e raised to IU plus e raised to minus IU, as per the formula it will become what here, 2 times cos of u. So Among this, again you take 1 upon if you take 2 common, because 1 into 2 is 2, 2 cos u it will be. If you take 2 common, so it will be, if you take LCM, it will become 1 minus cos of u whole divided by u square. So therefore f of u is equal to this 1 minus cos u, so we need to write in terms of sign, so 2 upon u square as it is. 1 minus cos u can be written as what here, 2 times sine square u by 2. So therefore finally it is 2 2s are 4, this is 4 upon u square into sine square of u upon 2. So reason is what here, so 1 minus cos of a is nothing but 2 times sine square of a by 2. So therefore finally f of u is equal to 4 sine square u upon 2 whole divided by u square is the required Fourier transform. Is the required Fourier transform. Now, but we need to find what here, as per the given question, we need to find, uh, we need to evaluate or deduce, we need to evaluate integration 0 to infinity sine square t upon t square into dt is equal to pi upon 2. We need to simplify this part. So therefore to simplify this part, we know that always we need to consider inverse Fourier transform. So by inverse Fourier transform, what we have here, it is nothing but f of x is equal to 1 upon 2 pi integration minus infinity to plus infinity capital F of u e raised to minus I u x into du. So this f of u is nothing but what we got f of u, we will consider that one now, and therefore I will write it like that, 1 upon 2 pi integration minus infinity to plus infinity, f of u is nothing but as per what we got previously, so 4 sine square u upon 2 divided by u square into e raised to minus I u into du is equal to this f of x, I will write on the right hand side, into f of x. So therefore here we'll start the manipulating first. So we don't want this term, because if you replace this all u by t, will get the required deduction part. What we have just see here, almost we have sine square t upon t square we needed, so we can manipulate here, but this is extra, so this extra we can remove by putting what here, by putting u is so x is equal to, by putting x is equal to 0, what happens here, so 1 upon 2 pi integration minus infinity to plus infinity 4, this 4 I will take outside, 4 upon 2 pi 4 sine square u upon 2 divided by u square e raised to iu 0, that is e raised to 0 into du is equal to f of 0. So here e raised to 0 is 1, and we have f of x is equal to what here, f of x is equal to, already we know that it is nothing but 1 minus mod of x. If you put f of 0 here, 1 minus mod of 0 is 0, which is nothing but 1. So therefore both the values we got, will replace it, what is f of x and what is e raised to 0. So 4 upon 2 pi will become what here, 2 upon pi integration minus infinity plus infinity sine square u by 2 divided by u square e raised to 0 is 1 into du is equal to f of 0 is 1. So once we got this, then again we need to go for the final simplification. Here you can see here, so we have u upon 2 and here we have u square. So for this u square I want to make this also u upon 2. So therefore what we'll do, 2 upon pi integration minus infinity plus infinity sine square u upon 2 divided by this for here will divide and multiply, that is what here will multiply and multiply by 4 and divided by 4 of u square into du is equal to 1. So which will become what here, 2 upon pi integration minus infinity plus infinity, this 1 by 4 as it is, sine square of u upon 2 divided by, so this u square upon 4 will become what here, u upon 2 whole square into du is equal to 1, because what angle we have divided by also we needed same, so that we can replace easily. So this 1 by 4 will take outside, it will become 2 upon 4 pi integration minus infinity plus infinity sine square u upon 2 divided by u upon 2 whole square into du is equal to 1, or it will be 2 ones are 2 twos are 1 upon pi, 1 upon pi you cross multiply to the right hand side, so it will become minus infinity plus infinity u upon 2 divided by u upon 2 whole square into du is equal to pi, because 1 upon pi 2 pi is left here, so 1 upon 2 pi, 2 pi if you cross multiply to 1 is equal to 2 pi, or replace or put u upon 2 is equal to t. So therefore what happens here, differentiate du upon 2 is equal to dt, or we can say that, or du is equal to 2 times dt. So therefore all replacement, it is nothing but minus infinity plus infinity sine of u upon 2 is replaced by sine square t upon t square, du is replaced by what here, 2 times dt is equal to 2 pi. This 2 you take outside, 2 into this minus infinity plus infinity can be written as what, 2 times 0 to infinity sine square t upon t square into dt is equal to 2 pi. This 2 twos are 4, cross multiply to the right hand side, integration 0 to infinity sine square t upon t square into dt is equal to 2 pi upon 4, because 2 twos are 4, so or 2 ones are 2 twos are here, so integration 0 to infinity sine square t upon t square into dt is equal to pi by 2. So which is a required deduction part of the given Fourier transform.